You've heard of Build-A-Bear. This is build a polynomial. So we've got polynomial p of x. It's to degree 4. It has a leading coefficient of 3, which will become important at the very end, actually. And it has some zeros. We know 2 is a 0. We know negative 1 is a 0. And we know 3 minus I, that's an I, is a 0. Now, degree 4, that's supposed to have 4 zeros, right? So we're missing one, but we remember from the problem above that the complex conjugate is also a 0, so that they occur in pairs. So we know that 3 minus I is paired with 3 plus I. Those would be our 4 zeros. All right, let's get ready to rumble. So what we're going to do is we're going to build polynomial p. All right. Now, I'm going to put in a little letter A out front. I don't know how your professor teaches this, but there might be an adjustment to be made at the end to end up getting this leading coefficient that we want. If it happens automatically, then we just let A equal 1. If it doesn't, then I'll show you how that works at the end. Okay, so now the zeros being these things mean that we know some factors. A 0 being 2 means that x equals 2, or x minus 2 equals 1. This 0 being negative 1 means that x equals negative 1, or x plus 1 equals 0. Okay. Then we've got 3 minus I, which translates to x minus 3 minus I as the next factor. And the last factor will be x minus 3 plus I. All right. Like I said, let's get ready to rumble. This is a long, tedious process, so we want to be real careful as we work through this. Now, a couple of choices. First thing I'm going to do, I think, is multiply these two together, because it'll get them out of the way. All right, so x squared, I'm going to do my FOIL, right? Minus 2x plus 1x would be negative x in the middle, minus 2 at the end. So that takes care of these two. They went there. Okay. Now for these, I'm going to prepare them first. I'm going to make them just a little prettier. So I'm going to take this negative and distribute it through and make it x minus 3 plus I. And this one, same deal, x minus 3 minus I. All right. Now, my choice is actually going to be to multiply these two together next. And the reason I do that is because a lot of stuff is going to drop out of these as we do that. And then I'll have a simpler thing to multiply times this when I'm finished. So for now, I'm just going to keep track that this is out front by writing it there. Okay, so now, boom, here we go. Now we want to make sure each term of this gets multiplied by each term of this. I'm going to do the x times everything first. So x times x is x squared. X times negative 3 is negative 3x. Oops, sorry. X times negative I is negative ix. Now, negative 3's turn. Negative 3 times x is negative 3x. Negative 3 times negative 3 is a positive 9. Negative 3 times negative I is a positive 3i. All right, last bit here. Positive I times x is positive ix. Positive I times negative 3 is negative 3i. And positive I times negative I is negative I squared. Okay, so now let's inspect this here and see what we can put together. So I will, again, copy that front half. There's that. Okay, so now in here, I have a lot of stuff. So x squared, that's the only x squared I have. So I'm going to copy that down, and that's taken care of. Negative 3x, and here's another negative 3x. So I'm going to put those together. I don't see any other number x's. I do see some ix's. We'll deal with that in a minute. No other number x's. So negative 6x. All right, now I have some ix's. I have negative ix here and positive ix here. See, I told you some of this stuff would fall out. All right, so that actually goes away. Let's see. Let's take care of these. I've got a negative 3i and a positive 3i. Boom, boom, all gone. Now, this may not look like it matches, but it actually does, because I know that I squared is negative 1. So what I'm looking at here is a negative 1 or a positive 1. Okay, and that positive 1 can be added to 9 to make 10. All right, see how pretty that turned out? It's not bad at all. Hardly even scary. All right, so again, I'm going to leave my a out front because actually I notice here when I multiply these two together to make my highest degree term, I'm going to have a coefficient of 1, so I will need to adjust it. All right, we're going to do this just like we did this. Each of these gets multiplied by each of these. Oops, each of these gets multiplied by each of these in turn. Okay, so let's start with x squared times x squared, x to the 4th. X squared times negative 6 is negative 6x cubed. 1, 2, 3. All right, x squared times 10 is 10x squared. Negative x times x squared is negative x cubed. Negative x times negative 6x is a positive 6x squared. Negative x times 10 is negative 10x. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to get here. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 6x would be positive 12x. Running out of paper. All right, negative 2 times 10 would be negative 20. See, these are the impressive problems that fill up a whole sheet of paper. Don't you feel great when these are done? All right, so putting things together like terms. So we only have 1x to the 4th term. That's right there. X cubed. There's one. There's one. That's it. So we've got negative 7x cubed. All right. X squares. There's one. There's one. There's one. All right, so we've got 10 plus 6 is 16, minus 2 is 14, x squared. All right, x's, there's one, there's one. So 12 minus 10 is 2. Sorry. And a minus 20. All right, so here's our basic 4th degree polynomial, and this one does have these roots. The only thing it doesn't satisfy yet is this. We need a leading coefficient of 3. Leading coefficient means the coefficient next to the highest power. So we can rectify that pretty easily. If it were more complicated, we would have to solve a little bit. But here I can just see that if I multiply this whole thing through by 3, if a is 3, then I'll get 3x to the 4th and so forth. All right, so we'll make a 3. All right, so when we multiply that all the way out, we'll get 3x to the 4th minus 21x cubed plus 42x squared plus 6x minus 60. Ta-da! All right. Now, if this had been more complicated, if this had been like a 1/2 or something, we would have had to make a maybe 6. You know, if 6 times a half would make a 3 out front. Okay, so that kind of thing. So if this is not 1, it'll be a little more complicated than this. But if it's just 1, then you can see that you just have to change. You just have to multiply through by the number you want. All right, and it only has to be this one that is affected when they talk about the leading coefficient. Okay.